This is question 2c. This is the 2015 NCEA 2 final exam for algebra. So let's have a look at this one here. And it's got, really it's just a quadratic, or quadratic in disguise, as people will tell you. But the key thing about this, of course, is it's using what we call fractional indices, which are really a very simple thing to navigate around. All we're going to do is say, well, I've got a u to the power of a third and a u to the power of 2/3. If you ignore the third bit, really this is u to the power of 2, u to the power of 1. Or we could replace those with x's. So why don't we just do that? So I'm going to say let x equal, and I call it u to the power of 1/3, which of course means that x squared is going to be u to the power of 2/3. Yeah, and really there's no difference between this, thinking about it this way and thinking about it that way, except we're going to have to turn it back as we solve. So let's just do that, nice and simple. So I'm going to restate the problem now, substituting an x every time I see a u to the 1/3, and an x squared every time I see u to the 2/3, which only occurs once each anyway. So nice and simple. This implies that, therefore, we've got a 2u, which is going to be a 2x squared, plus 7u to the third, which is 7x, is equal to 4. So I'm just going to subtract 4 from both sides. There it is. So this now equals 0. So I've now got 2x squared plus 7x minus 4 is 0. So we've got a basic quadratic. Let's just go solve for this one. And I'm actually looking, oh, look at this, looking above, and we've actually already done this. So we've actually found that the solution to this thing here is this here. So we've already done this. Let's not double up on what we don't need to redo. Yeah. So I'm just going to write that implies, therefore, that x plus 4 and 2x minus 1 is equal to 0. So now we've got x's. Let's solve. So I can say either, or therefore, I'm going to put therefore either x plus 4 is 0 or 2x minus 1 is 0. But so, or therefore, x is negative 4 or x is equal to, and this would be 1/2. All right, just solving in the usual way. Now, of course, we don't really want to find out what x is. X is like that and that, but we know if although x is a negative 4, when x is a positive 1/2, x is not just there. It's u to the 1/3 is the 4, and u to the 1/3 is the 1/2. So let's go ahead now and solve for u. We've solved for x, so we can say if x is negative 4, therefore we can say that u to the 1/3 is equal to negative 4. Yeah? And if that's the case, let's find out what u is. So to undo a third, if we just put that to the power of 3, in other words, the reciprocal of whatever the index is inside, I could go 3 on 1, but I'm just going to say 3, then a third to the power, third times 3 is just 1, which is just u. And of course, this to the power third must do the same thing to both sides. Negative 4 times negative 4 times negative 4 is negative 64. So because we'll put here either u is that, or we could say u is, and we've got u to this time to the power of 1/3 is equal to, we've got a 1/2 down here. So I'll put a 1/2 here, 1/2, there it is. And I'm going to put that to the power of 3 now to get rid of the third. This is to the power of 3. So so u equals, well, 1/2 times a 1/2 times a 1/2 is going to equal 1/8. So we can say u is an element of set of, and I'll do it in order, negative 64, the smallest one first, comma 1/8. Or you could say either u equals negative 64 or equals 1/8. Hopefully that makes sense.